Assalamualaikum and salam sejahtera to all of you. Welcome back to our topics on MEC 333 Building Services. So for today's video, we're going to discuss more on Chapter 7, which is the vertical transportation. So in this video, we're going to discuss about vertical transportation system and its operating principle and the types of vertical transportation and its application. So after watching this video, hopefully you are able to describe and illustrate system and operating principle of a vertical transportation and identify and differentiate the types of vertical transportation and its application. So vertical transportation is defined as a transport devices which primary use is to transport in a vertical direction. It has various types of devices such as a cable car, elevator, escalator, travelator, ramp, even a hot air balloon, and etc. So the purpose of having this kind of transportation is to ease human. Vertical transportation related to building usually are lift, paternoster, escalator and travelator, and ramp. So now we're going to discuss more on lift. Lift has been used widely to buildings that have more than 4 stories. We know that lift is a machine that provides comfort to people where it provides vertical transportation in a building with ease and fast. Lift can be categorized as a sophisticated machine which applies on various systems. Fortunately, in this modern day, the lift has been upgraded technically by a program devices, safety practices, and even on its regulation. Lift operating principle. The lift car moves in a specially constructed vertical chamber within a building. The lift car is driven up and down along guide rails by a drive machine which is connected to an electric motor. This direction in which the lift car moves is controlled by a drive controller. The drive controller determines the direction of the car movement according to the position of the car, the call button, and the floor button pressed by the user. When the lift car arrives at the floor where a stop is required, the sensing circuit will inform the drive controller to stop the car there. After the lift car is stopped, the car door and the landing door open together automatically. One lift can transport up to 20 passengers from one floor to any other floor at one time. They are suitable for high-rise building. Lift is necessary in all buildings over 3-story high. It is essential in all buildings over a single story if they are accessed by the elderly or disabled. Minimum standard of lift per 4 story. Floor space and lift car capacity can be estimated at 0.2 meters square per person. This is the suggested car speed for lift. Go good electric or hydraulic, the car speed move at 0.2 to 1 meter per second. For electric lift passenger less than 4 floor, the car speed is 0.3 up to 0.8 meter per second. For 4 up to 6 floor, 0.8 to 1.2 meter per second. 6 to 9 floor is 1.2 to 1.5 meter per second, where 9 to 15 floors is 1.5 to 1.7 meter per second. Usually, lift can be divided into 2 types, which is traction lift and hydraulic lift. For traction lift, is powered by an electric motor, either AC or DC, which is coupled to the hoisting mechanism through a reduction gear. The motion of the car is obtained through traction between the suspension ropes and the driving sheath, otherwise known as a cable lift. So for hydraulic lift, it's driven by a pump which raises or lowers the lift car by varying the oil pressure in a ram. The pump is driven by an electric motor. For traction lift, it's going to be divided into two types. Either it's geared or gearless. For geared, the car is supported in a hoist way by steel hoist rope, a sheath, and a counterweight. The car and the counterweight ride along vertical guide rails. In a geared machine, the drive sheath is connected to the motor shaft through gears in a gearbox. This equipment is designed for mid-to-rise application of 5 or more floor requiring typical speeds of 350 feet per minute. For gearless traction lift, the car is supported in a hoist way by steel hoist rope, sheaths, and a counterweight. The car, counterweight, and guide rails operate like those in geared system. The gearless machine has a motor that connects directly to the shaft of the drive sheath. The equipment is designed for high-rise application of 10 or more floor requiring typical speed of 500 or more feet 2 to 3 per minute. This is the example of a traction lift, where you can see the actual picture of the lift, the 3D dimensional of the lift, and the illustration of the mechanism having on a traction lift. Hydraulic elevators are one of the two types of elevator which are used in the modern world. The other being the rope system elevator. Hydraulic elevator works on the simple system of a hydraulic ram. This ram, which incidentally gives the types of leads its name, has a fluid-driven piston mounted inside its outer cylinder. This cylinder is connected to a fluid pumping system. This incompressible fluid is generally oil, but other variations are sometimes found. The fluid is pumped into a pipe leading to the cylinder, and after various mechanical happenings, the fluid ultimately begins to collect in the cylinder, and this begins to push the piston up. This is what moves the elevator car, which has the passenger inside. To lower the elevator car, the reverse happens and the fluid is slowly leaked out. This causes the car to slowly descend, and when the elevator has reached its destination, the valve is closed and the fluid level stays constant. We have three types of hydraulic lift, which is the direct plunger, holeless, and rope. For direct plunger, a car is connected to the top of a single section piston that moves up and down in a cylinder, which is below ground level. The car moves up when hydraulic fluid is pumped into the cylinder from a reservoir, raising the piston. Hydraulic systems are used primarily in low-rise installation where moderate car speed is required, up to 150 feet per minute. The typical extent of a travel is 40 feet. Do not exceed a maximum travel length of 44 feet or a maximum building height of 4 floors. Holeless hydraulic lift, the car is connected on each side with a single section piston that move up and down in a cylinder, which is mounted on top of the pit floor. The car moves up when hydraulic fluid is pumped into the cylinder from reservoir, raising the piston. Car speed up to 125 feet per minute is attained and maximum travel length is 12 feet. For rope hydraulic lift, the car is supported by steel hoist ropes and shifts, which are moved up and down by holeless single section piston in a cylinder. Car speed up to 150 feet per minute. It attained and maximum travel length is 48 feet. Here is an example of a hydraulic lift, where you can see in the figures the actual of a hydraulic lift and its schematic diagram. The difference between traction and hydraulic lift. For traction lift, lift by ropes which pass over a wheel attached to an electric motor above the elevator shaft. Used for mid and high-rise application, much higher travel speed than hydraulic. Components, control system, shift, motor, counterweight, guide rails. The machine room is located at the uppermost level. While for hydraulic, supported by a piston at the bottom of the elevator that push the elevator up as an electric motor force oil or another hydraulic fluid into the piston. Used for low-rise application of 2 to 8 stories. Components must have tanks, motor, valve, actuator. The machine room is located at the lowest level adjacent to the elevator shaft. This is figures from traction lift where we have a control panel, a safety circuit, inspection box, and the figures of motor. Here we have a cable and a governor. Hydraulic buffer, counterweight, lift brake, lift beam for maintaining purpose. We have a lift door, door lock, door sensor, while inside the lift we have button operation, permit number, lift number, smoke sign, ventilation, lift information, and emergency light. Lift safety. A lift must equip with fire alarm, a door equipped with sensors. If it's out of alignment, it will stop the door from closing. Passenger trap within 50 minutes. It also have brake system related to speed of a car lift ventilation. Quantity 2 each unit emergency or backup. Then it also must have light, intercom, or lift phone. Lift construction stage. First is from the civil engineer to provide space and design shaft. Then contribute to contractor lift, which will install the lift. Then to mechanical engineer or specialist to set up the lift operation. Then come to Jabatan Keselamatan and Kesihatan Pekerjaan JKKP to inspect and give permit. Lift requirement. The lift must have weekly maintenance. regular systematic cleaning, inspection, lubrication and adjustment, collect 1 chip per month for every year 12 chip to be collected, inspect by Jabatan Keselamatan dan Kesihatan Pekerjaan JKKP. It will involve 3 parties, which is JKKP, the owner and competent contractor, where the fail to meet the requirement of inspection will lead to be fined and close operation of the lift. This is a rough lift maintenance cost. Per week is equivalent to RM 400 for 1 to 5 floor, while RM 800 for 5 to 10 floor. Lift electricity, it will be low in cost because electricity only used if lift is operating. Another device used in vertical transportation is paternoster. A paternoster or paternoster lift is a passenger elevator which consists of a chain of open compartments, each usually designed for 2 persons, that move slowly in a loop up and down inside a building without stopping. Passengers can step on or off at any floor they like. Another type of vertical transportation is escalator. It is a conveyor transport device for transporting people, consisting of staircase whose steps move up or down on tracks that keep the surface on the individual step horizontal. Most escalators have a moving handrails that approximately keep pace with the movement of the steps. The direction of movement up and down can be permanently the same or be controlled by the personnel according to the time of day, or automatically be controlled by whomever arrives first, whether at the bottom or at the top. In low to medium rise buildings, they will compete favorably with lifts, even though they only move at between 0.5 to 0.65 meter per second. In high-rise buildings, the space will not be justified and the modern high-speed lift provides a superior service. Where large number of people are anticipated, such as airports and railway terminals, the angle of indication is normally 30 degrees and can increase to 35 degrees if the vertical rise does not exceed 6 meters and the speed is limited to 0.5 meters per second. Escalator design. Modern escalators have a metal step in a continuous loop that move on tracks. Escalators are typically used in pairs with one going up and the other going down. Some modern escalators in stores and shopping malls have glass slides that reveal their workings. Most escalators are straight. Some shopping malls use curved version. This is some of the escalator arrangement where we have a single bank, which is the traffic in one direction, double bank, traffic in 2 directions, crisscross, parallel, and spiral. So this is a picture of a single bank escalator, double bank escalator, crisscross escalator, parallel escalator, Spiral escalator. Travelator is a moving walkway, moving sidewalk. Travelator is a slow conveyor belt that transports people horizontally or on an incline in a similar manner to an escalator. In both cases, riders can walk or stand. The walkway are often supplied in pairs, one for each direction. Moving walkways are built in one of two basic styles. Pallet type, a continuous series of flat metal plates joined together to form a walkway. Most have a metal surface, though some models have a rubber surface for extra traction. Moving belt, these are generally built with mesh metal belts or rubber walking surfaces over metal roller. The walking surface may have a solid feel or a bouncy feel. Both types of moving walkway have a groove surface to mesh with comb plates at the ends. Also, nearly all moving walkways are built with moving handrails similar to those on escalators. Pallet types consist of one-piece die-cast aluminum pallets. Example dimensions are width between 800 mm to 1200 mm with a speed of 0.5 meter per second, powered by an AC induction motor. RAM is an inclined plane. It is not a machine and does not move. Many devices based on the principle of the inclined plane allow expending less force to achieve a task. Ramps enable accessing heights that would be too difficult to scale vertically. Ramps allow heavy objects to ascend to and descend safely from a high-level bridge. Here is an example of a ramp, where we have a vertical ramp and a spiral ramp. With the last slide of the presentation, it comes to the end of our video. So hopefully you are able to differentiate the types of vertical transportation related to building services. Hopefully to see you in the next video. Assalamualaikum and goodbye.